Welcome everybody to SSH tunnels. I have taught SSH tunnels a number of different times in my time. It is definitely one of the trickier subjects of red team operations to understand. Whenever you're doing a big assessment, especially if you're doing some pretty tricky stuff, you're going to be tunneling traffic point to point through hosts, tunnels attached to tunnels. And once you understand what a tunnel is and how it works, I really think of it almost like pipes transferring water, right? So you learn how to hook the pipes together and you can route traffic wherever you want. You can do so many cool things with tunnels inside of tunnels, bypassing all sorts of cool things. But again, understanding the foundational base concept can be challenging. I put together some images we're going to talk through. We're going to mark them up and hopefully it makes a lot more sense before we jump in and run some of the different commands. So welcome to our first drawing here. I actually marked out one of the two tunnels we're going to be discussing throughout this RTFM section, the SSH TAC L. And you can see it right here, SSH TAC L. Whenever you see SSH TAC L, I want you to think L local, okay? We're going to be running an SSH TAC R later on. I have a different drawing for that. SSH TAC R is remote. So TAC L local, TAC R remote. And this is going to help you because TAC L local means it's going to open the port on your local machine, and then the TAC R is going to open the port on the remote machine. So let's take this big chunk right here. We have an IP address, and then we have the port. The port is 3389. So again, taking this section here, TAC L, let's open it up on our local machine. So let's say we were running it on our Kali box right here. You can see our Kali IP address, 172.30.156. So it's telling SSH, open port 3389 on our Kali box right here. So I'm going to go ahead and create a little red dot to annotate that a port has just been opened. So this is port 3389. It has now been opened, like I discussed, TAC L local. We gave it an interface and a port. The port is open. It's bound, okay? Whenever you see this colon right here, and I'm going to make it ultra big so we don't miss it, I want you to think this is where the SSH tunnel comes into play, okay? So all the traffic, whenever this colon in the middle of the two sets happens, the traffic is going to be sent through the active SSH session. So if you want to look towards the end of the command, you can see this is the SSH session. It's going to SSH over to our redirector like we've been doing this whole time. So all the traffic is going to traverse our SSH session, which is the green arrow in our diagram right here. And then it's going to evaluate the last half of our tunnel command, which in this example, we're then going to forward the traffic to 172.30.157, which is our Windows attack. We haven't really touched it yet in the series, but it's going to go ahead and tunnel all the traffic to that host against its port 3389. So you can, if you're feeling fancy, you can change the port so it actually pulls in on a port and then sends it to a separate, different port. Now, if I was to draw the flow of traffic, so with this tunnel established exactly like we've talked about, exactly how we see here, any traffic entering port 3389 here is going to come up through our SSH tunnel. And a little bonus information, since it's traveling through the SSH tunnel, it's encrypted, it's protected, right? It's going to come from the redirector, evaluate that second half, and it's going to say, oh, I need to send it to 57. So it's going to continue on its journey to the Windows attack on 57. Now, the cool part about this tunnel, as you can see, if there was some type of person watching this traffic, let's say they're sitting on the Windows attack here, they would see all the traffic coming from the redirector, not from the Kali machine that's hiding behind the redirector. So I hope you enjoyed that 10,000 foot view. That's an SSH TAC L tunnel. Now let's look at our SSH TAC R tunnel, which we're going to use to set up our redirector and infrastructure in the next scenario video. So clicking over to our SSH TAC R, you can see very similar layout here at the bottom. I did drop our Windows attack host from our diagram, so this should be a little bit easier to understand. Before we jump in too deep, I do want to show you the 0.0.0.0. I want to explain. This means listen on all interfaces. Let's say our redirector had 5 different IP addresses. This is going to tell it to listen on every single IP address, little shorthand notation. So don't be too intimidated by that. We also have our 127.0.0.1 here. That is shorthand notation. I've been using it a little bit already. That is shorthand notation for send it to myself. Good example, if you wanted to SSH to yourself rather than putting your own IP address, you can just do 127.0.0.1 and it'll send it there. So let's evaluate this tunnel. Let's see what it's doing. TAC-R remote, it's gonna run it on the redirector. It's gonna go ahead and listen on all interfaces on port 443. Now port 443 is general, just HTTPS internet traffic. It's a great example here if we were setting up like a fake website. So port 443 is good for this example. Anyway, listening on all interfaces, opening up port 443, and I'm gonna go ahead and put our red circle here, and then it's going to evaluate our colon. And if you remember, we gotta think this is where the SSH tunnel comes in. So again, we make it really big here so we know, and this is the point when the traffic is gonna traverse our SSH tunnel, so it's gonna connect back through SSH to our Kali machine, and then from our Kali machine's perspective, it's going to send all that traffic against itself, 127.0.0.1 on port 443. Now again, if I were to draw out a traffic flow, if we have the internet over here traversing, coming into our redirector on port 443, it's going to come up, go through our SSH tunnel, again, encrypted in our SSH tunnel, to our Kali machine. It's going to come to our Kali machine, and then our Kali machine is just going to say, nope, send it right back to myself. And we're going to talk a lot about redirectors and why we use them, but this is just a great tunnel to set up to take all the traffic from an external host and then send it back through your SSH tunnel to yourself. All right, hopefully this is all making sense to you. Let's see some of this in action and see how we can make this work. Now, looking at an overview of our SSH port forwarding RTFM section, there are some configurations that we have to change first before we do any SSH tunnels. So looking at the RTFM, we're gonna nano etc SSHD config here, and then we're gonna look for two lines. We're gonna look for allow TCP forwarding and gateway ports. So we're gonna allow TCP forwarding, allow our gateway ports, make sure to go to yes. This is gonna make sure the advanced features of SSH, some of the tunneling we're gonna do, is gonna work successfully. So we're gonna SSH up to our redirector. We've been doing this a bunch. As you can see, I didn't have to type in my password. I'm assuming it remembered it for my SSH key here. And we're gonna do that same configuration change. So make sure you do a sudo nano. That will make sure that you can change this file because it does require administrative privileges. So jumping down here to the files that we wanna get to. Allow TCP forwarding, gateway ports, yes. Excellent. So we are good to go there. Now we're going to make sure to restart our SSH service. So we're going to do service SSHD restart. If that doesn't work, you can try to restart just SSH. Just depends what your specific Linux distribution kind of loaded the SSH service as. And then up here on the redirector, we're going to restart our SSHD service as well, but we're going to use systemctl because this service program is not installed on the redirector. So as you can see here, we have sudo systemctl restart SSHD. And again, restarting these services is just to make sure that our configuration changes are applied. Now that our configurations are updated, let's go ahead and see what we have here. I will show this one a little bit later. Let's get just a basic tunnel set up first. So we're gonna demonstrate the SSH TAC-R. Like I said, SSH TAC-L used in different situations. It's inputted very similarly, right? So we're gonna set up our SSH TAC-R very similarly to how I diagrammed it. So let's go ahead, we'll exit, we'll run our clear. Let's do an SSH TAC-R 0000, grab port 443. It's gonna go through our SSH tunnel, back out, and we're actually gonna send it to ourselves on port 8080. And that's because I'm gonna set up a little web server and we're gonna see how it works. So let's finish out our command here. We do rogue operator at 172.100.1.0. Before I enter the command, I do want to show you that this doesn't work, right? So let's do HTTP 172.100.1.10. Boom. Doesn't work. There's nothing there, right? Because our remote redirector, our .10, is not listening. And I should technically have port 8080 over here. It is not listening on port 8080, but I can change that. So let's come back here. We want port 8080 open. So I'm gonna set up just a simple Python 3, we're going to do a TAC-M http.server. I believe this one's in the RTFM. If it's not, this is a fantastic way to transfer files between hosts in a lab environment. Please understand this is not authenticated, so anyone can browse and download my files. But I'm going to go ahead, fire this up, listening on 8080. So now let's put our tunnel in place. Again, we're going to open port 443 on the redirector, which I'm actually going to change that. Let's just change it to 8080. Reason being, sometimes web browsers are like, oh, I'm supposed to connect over HTTPS, but that's not the case. So SSH 8080, we're going to transfer it through the SSH tunnel back to myself on 8080. Fire that off. Excellent. And now we're going to open up our browser here, and we're going to browse to our redirector on that port 8080. Boom, loaded. Perfect. So again, all of this traffic, our web browser is going out to the remote machine, hitting that port 8080 that was opened by our SSH tunnel, traversing through our SSH tunnel, and then landing on our Kali machine. And we can further prove that by looking at our web log here. As you can see, it says, hey, someone's browsed into our website from ourselves, which we know is not the case. We browsed that external server, but then again, tunneling, coming back, boom, hitting ourselves. Now, another common tunneling technique is the SSH TAC-D function. So if we bring up our RTFM here, we'll scroll down, look at our SSH TAC-D right here. It's very easy, almost easier than our last one. You do your SSH TAC-D, enter in a port, and then remote login SSH to your target, and it's actually going to set up a SOCKS proxy listening on that port. Now, the cool thing is you can set your web browser to that local port, and then all of that web browser traffic is actually going to be tunneled through your SSH session out into the world, and it's going to look like it's coming from that redirector. Definitely comes in handy, specifically in red team operations. We use SOCKS proxies a lot to tunnel our web browsers through just a bunch of different tunnels, a bunch of different machines through our malware to actually browse resources as whatever machine we've taken over. So let's go ahead and set up our SOCKS proxy here. We're going to do SSH TAC-D. I'm going to use port 8888, and then we're going to do our login against our remote here. It's going to log me right in. Cool. If you do the SSH TAC-V, you actually get a lot more information. It's like verbose, right? And if you scroll up, you can see local port forwarding listening. And that's how you know it's working successfully. So let's open up Firefox here. Let's go to settings. We're going to open up our proxy. Excellent. And then we're going to do a manual proxy configuration. And here, proxy information, we want to make sure is 127.0.0.1. Make sure our port is 8888. Click OK. And now all of our web traffic is being tunneled through our redirector. So let's try to access our Kali machine's open web browser, right? So let's go ahead. Let's see what our Kali IP is, because I forgot. So let's grab our IP address here, copy, go to Firefox. We're going to try to browse to our Kali machine on that port 8080. Again, I set up that web server, right? So we're doing our browse here, loads, and again, we can confirm it's coming from the correct target by opening up our terminal here, coming back here, and you can see, hey, I found web traffic from our redirector. So our local browser sent the traffic to our local SOCKS port, which then was tunneled through to our redirector, and then we browsed back to ourselves. So many potential options to use with all of these tunnels. Honestly, there's never a perfect way to set up a tunnel. And I used to say this in some of the classes I taught that were more advanced. There was a lot of different tunneling options to pick from. Typically, I said, I'm going to try to communicate the easiest to understand method, but there's some really cool, exotic ways you can set up tunnels that are more efficient, run better, and that sort of thing. Now, the last thing here that's in the RTFM, if you scroll down here to proxy chains allows you to run tools through SOCKS proxies, and they work really, really well. So let's go ahead and set up Nmap to use proxy chains. So we're going to do nano etc proxy chains. We're going to scroll all the way down. We're going to go ahead and set the port that we just set. So I believe our SOCKS proxy was open on port 8888. Close it. Now we have our proxy chains config set up perfectly, and I have an Nmap that I've preset up here for us. Now I don't cover Nmap specifically in this video series, so really quickly here we have TAC-ST, full TCP connect, do not ping the target, do not resolve DNS, target this IP address on port 8080, which, if you recall, we do have open, we have our web server open on our Kali box here. So what's gonna happen is Proxy Chains is gonna route all this traffic to our redirector, back out towards ourselves, so we should see a port open. Perfect, we have our port open here. Proxy Chains has successfully tunneled all that traffic through our redirector back to ourselves on port 8080. So that's the end of SSH tunneling. As I mentioned, one of the harder things to understand. And if you think you're starting to understand it, great job, pat yourself on the back. Definitely a tough subject. But if you want more, click through to the next video. I cover TCP dump, which is an awesome tool used to dump network PCAP off of a box.